All right, benchmark 14. I can solve real-world problems using ratios and percents. I need you to write down these two definitions. Percent increase is the percent amount of something that gets bigger, and percent decrease is the percent amount of something that gets smaller. So in this benchmark, you'll be able to find the percent increase and decrease of two amounts, and also be able to find the percent of a number and a few other examples in this benchmark. The first example we're going to look at is finding the percent of a number. So if we look at this word problem, what is 30% of 200? We're going to use the formula is over of equals percent over 100. So if we think of 100% of 200 is 200. 50% of 200 is 100. That's half of 100. So we know 30% has to be less than 100. So that's just going to help us keep this in mind when we check our answers. So the is always going to be your x for your variable. The of is always going to be the number that's right after the of in the word problem. And then your percent, which is 30, will always go over 100. So in this case, the reason percent goes over 100 is because 30 over 100 equals 0.3, which is another way to write 30%. So we're just writing 30% in fraction form in our ratio. Our next step would be to cross multiply and divide. So we're going to do 200 times 30, which is 6,000. And then we're going to divide by 100, which is 60. So 30% of 200 is 60, which is less than 100. So we know we probably did our work correctly. The next one we're going to look at is what is 25% of 89. So we're still going to use the is over of equals percent over 100. This is our formula for solving these problems. So remember, our is always the x, the of is 89, what we're finding the percent of, and then our percent 25 over 100. This will always be 100 down here. So we cross multiply. 89 times 25 is 2,225, and then we divide that by 100, and we should get 22.25. So 22.25 is 25% of 89. Let's do one more example. Try this one on your own, and then pause the video to work it out, and then restart it to see if you got the problem right. So this one, still use is over of equals percent over 100. So our is again is x, our of is 14, our percent is 56, 100 will always be on bottom. And then we cross multiply. 14 times 56 is 784, and then we divide by 100, and you should get 7.84. Now 50% of 14 is 7. 56% is a little bigger than 50, so it makes sense that our number is a little bigger than 7. So we know that we probably did this one right as well. When we calculate the percent change, there's 3 steps that we need to do. Our first step is to subtract. So we're going to subtract her starting value and what she makes now in this case. So we're finding the difference of the two. So we're going to do 3,673 minus 3,105. We're finding the percent increase of Jenny's salary. So when we subtract these two, we get 568. Step 2 is to divide and we're going to divide by the starting value. So this is what she started with. So we're going to divide the number from step 1, 568, divide it by her starting value, 3,105. And you should get 0.182, and just round to 3 decimal places. And then your third step is to change it to a percent, so we're going to multiply by 100. So we're going to take 0.182 times 100, which would be 18.2%. So her percent increase for her salary was 18.2%. In this case, we're going to find the percent decrease. So our first step, if the temperature fell from 93 degrees to 78 degrees, is to subtract. So 93 minus 78 is 15. And our second step is to divide. So we're going to do 15 divided by our starting value, which is 93, which is 0.161. And then our last step is to divide or multiply that decimal times 100. So 0.161 times 100 is 16.1%. So the temperature decreased by 16.1%. So make sure you wrote those steps down on the last slide, that we subtract, divide, multiply by 100. This next type of problem is a little different than the last. This one says Katie earned $11 an hour and got a 12% raise. How much does she make now? So in this one, our first step is to change the percent to a decimal. So 12% as a decimal is 0.12. Our second step is to multiply the value, which in this case is $11, times the decimal, which is 0.12. So 11 times 0.12 is 1.32. So this number is not our answer, but that means she makes $1.32 more an hour. That's 12% of 11. That's how much more she makes. So since she got a raise, we're going to add $11 to what she's making more. So her total salary is $12.32 an hour. This example is similar to the last one. It says the grizzly bear population in Yellowstone National Park in 1980 was about 230. Over the next 34 years, it increased about 70%. What's the population of the bears? So we have to first change 70% to a decimal, which is 0.7. Then we're going to multiply 0.7 times the value, which is 230. And that equals 161. So again, that's not our answer, but that means there's 161 more bears than there were in 1980. So our last step is to add 230, which was our starting value, to 161. So you should get 391. So that's a 70% increase in bears. So there should be about 391. This is the end of benchmark 14 video.